Good morning. Today we have to take one more concept about condenser. Condenser or capacitor. Today we have to see one more point about condenser or capacitor. The ability of conductor to hold charge. The ability of conductor to hold charge is called capacity of conductor. What is capacity? The ability of conductor. Ability म्हणजेच क्षमता, कंडक्टरची क्षमता. The ability of conductor to hold charge म्हणजेच कंडक्टरची चार्ज होल्ड करण्याची जी ॲबिलिटी आहे त्याला म्हणतात कॅपॅसिटी ऑफ कंडक्टर. इफ some charges are added on conductor, then its potential increases. If some charges are added on conductor, then its potential increases. The increase in potential of conductor is directly proportional to charge added on that conductor. जर आपण एखाद्या कंडक्टरवरती काही चार्ज ऍड केले तर त्याचं पोटेन्शियल इन्क्रीज होतं. त्याचं इन्क्रीज होणारं पोटेन्शियल हे कशावरती अवलंबून असतं? द क्वांटिटी ऑफ चार्ज ऍडेड टू द कंडक्टर. इफ सम चार्जेस आर ऍडेड ऑन कंडक्टर, then its potential increases. The increase in potential of conductor is directly proportional to charge added, or it may be written as quantity of charge added is directly proportional to increase in potential. To remove this proportional sign, we have to take constant, that is C. This constant is called as capacity of conductor. This constant is called as capacity of conductor. SI unit of capacity, that is joule per volt, but convenient SI unit of capacity is farad, F-A-R-A-D. Actually, C is equal to Q divided by V, and therefore SI unit of capacity of condenser, that is Coulomb. SI unit of charge Coulomb. Potential volt means Coulomb per volt, but convenient SI unit of capacity is farad, and therefore 1 farad is equal to 1 coulomb divided by 1 volt. Means if 1 coulomb charge is added on conductor to increase 1 volt potential, if 1 coulomb charge is required to increase potential 1 volt, then capacity of that conductor is called as 1 farad capacity. What is 1 farad capacity? If 1 coulomb charge is required to increase potential of conductor by 1 volt, then capacity of that conductor is called 1 farad capacity. 1 microfarad is equal to 10 raised to minus 6 farad. 1 nanofarad is equal to 10 raised to minus 9 farad. 1 picofarad is equal to 10 raised to minus 12 farad. ही काही कन्व्हर्जन्स आहेत. म्हणजे मायक्रो फॅरेडचे फॅरेडमध्ये करताना 10 रेज टू मायनस 6, नॅनो फॅरेडचे फॅरेडमध्ये करताना 10 रेज टू मायनस 9, पिको फॅरेडचे फॅरेडमध्ये करताना 10 रेज टू मायनस 12 like this. This is about capacity of conductor. SI unit farad or coulomb per volt. Now, concept of parallel plate capacitor. Concept of parallel plate capacitor. Concept of parallel plate capacitor. The arrangements of conductors. The arrangement of conductors to increase its capacity. The arrangement of conductors to increase its capacity without increase in its potential. म्हणजे पोटेन्शियल इन्क्रीज न करता कॅपॅसिटी इन्क्रीज करणं, ही जी कंडक्टरची अरेंजमेंट आहे त्याला म्हणतात कॅपॅसिटर or is called as capacitor. What is capacitor? What is capacitor? The arrangement of conductors. आपण कंडक्टरची अरेंजमेंट करतोय कशासाठी? To increase its capacity without increase in its potential. Such arrangement of conductor is called as capacitor. What is capacitor? The arrangement of conductors to increase its capacity without increase in its potential is called as capacity of conductor. याचं प्रिन्सिपल असं आहे पहा, याचं प्रिन्सिपल असं आहे, द कॅपॅसिटी ऑफ कंडक्टर, द कॅपॅसिटी ऑफ conductor, the capacity of conductor increases if another conductor connected to earth kept near it. The capacity of conductor increases. कंडक्टरची कॅपॅसिटी वाढते. कधी वाढते? इफ अनदर कंडक्टर, दुसरा कंडक्टर, कनेक्टेड टू अर्थ केप्ट नियर इट. म्हणजे एखाद्या कंडक्टरची जर कॅपॅसिटी वाढवायची असेल, एखाद्या कंडक्टरची कॅपॅसिटी वाढवायची असेल तर दुसरा एखादा कंडक्टर विच इज कनेक्टेड टू अर्थ केप्ट नियर इट. म्हणजे कंडक्टरची कॅपॅसिटी वाढवण्यासाठी आपण दुसरा एखादा कंडक्टर त्याच्या जवळ ठेवतो विच इज कनेक्टेड टू अर्थ. एक्सप्लेनेशन. See, consider parallel plate condenser. Consider parallel plate condenser like this. Consider parallel plate condenser consists of two metal plates P1 and P2 किंवा two conducting plates म्हणा. Consider a parallel plate condenser consists of two conductors P1 and P2 separated from each other by air or dielectric between them. If charge plus Q is added on conductor P1, if charge plus Q is added on conductor P1, then an equal minus Q charge induced on near side of plate P2 and an equal plus Q charge induced on far side of plate P2. काय सांगितलं बघा. If charge plus Q is added on plate P1, then an equal charge minus Q induced on near side, ह्याला म्हणतात near side, ह्याला म्हणतात far side, या कंडक्टरची near side आणि far side, then an equal minus Q charge induced on near side of plate P2 and an equal plus Q charge induced on far side of plate P2. If plate P2, suppose this plate P2, if plate P2 is connected to earth, if plate P2 is connected to earth, then plus Q charge on plate P2 plus Q charge on plate P2 escape in earth and only charge minus Q remains on plate P2. जर आपण ह्या प्लेटला अर्थला कनेक्ट केलं तर हे जे पॉझिटिव्ह चार्ज असतात हे अर्थ मध्ये एस्केप होतात आणि त्याच्यावरती फक्त निगेटिव्ह चार्ज शिल्लक राहतात. इन ॲब्सेन्स ऑफ प्लेट P1 P2, समजा ही प्लेट नसती, इन ॲब्सेन्स ऑफ प्लेट P2, if phi and Q are potential and charge of plate P1, if phi potential of plate P1, Q charge on plate P1, then capacity of plate P1 is given by Q divided by phi. Suppose this is equation number 1. In absence of plate P2, समजा ही जर प्लेट नसेल, in absence of plate P2, if phi and Q are potential and charge of plate P1, then capacity of plate P1 becomes Q divided by phi. In presence of plate P2, in presence of plate P2, in presence of plate P2 minus Q charge on plate P2 minus due to minus plate charge in presence of plate P2 due to minus Q charge on plate P2, resultant potential on P1. Resultant potential on plate P1 is phi minus phi1. In presence of plate P2 due to minus Q charge on P2, resultant potential of plate P1 becomes like this, and therefore capacity of condenser, that is C2 is equal to Q divided by phi minus phi1. Suppose this is equation number 2. बघा या दोन इक्वेशन मध्ये काय सांगितलं, जर ही प्लेट नसेल तर फक्त याचंच पोटेन्शियल तयार होतं. ही प्लेट जर नसेल, in absence of plate P2, only potential on plate P1 is considered. But due to plate P2, due to this plate, potential suppose minus phi1, potential suppose minus phi1 produced on plate P2, and hence resultant potential at P1 becomes yacha potential phi, yacha potential minus phi1, resultant potential phi minus phi1. Charge on plate P1 remains same, यावरती असणारे चार्ज तेच आहेत, and therefore capacity becomes C2 is equal to Q divided by phi minus phi1. From equations 1 and 2, from equations 1 and 2, C2 is greater than C1, means capacity of conductor increases, capacity of conductor increases by placing another conductor near it connected to earth, means capacity increases with decrease in potential. This is our principle of capacitor. Okay, what is principle of capacitor? The capacity of conductor increases, the capacity of conductor increases if another conductor connected to earth kept near it, means in presence of plate P2 capacity increases but its potential, resultant potential decreases. Okay, this is about condenser, concept of parallel plate capacitor, capacitor, concept of parallel plate capacitor. Now we have to see one more term, that is capacitors in series combination. Capacitors in series combination. Capacitors in series combination, and one more, that is capacitors in parallel combination. Capacitors in series combination and capacitors in parallel combination. See, capacitors in series combination and capacitors in parallel combination. Plus minus plus minus plus minus. Suppose this one capacitor of capacity C1, C2, C3. If negative plate of one capacitor is connected to positive plate of next capacitor, इथं पण negative plate of one capacitor is connected to positive plate of next capacitor, then such a combination of capacitors is called capacitors in series combination. What is capacitors in series combination? If negative plate of one capacitor is connected to positive plate of next capacitor, then such a combination of capacitors is called as capacitors in series combination. In this case, see, positive, negative capacity C1, C2, C3. If positive plates of each capacitor is connected at a single common point like this, if positive plates of all capacitors are connected at a single point and negative plates of all capacitors are connected at one another single point like this. If positive plates of all capacitors are connected at a single point and negative plates of all capacitors are connected at one another single point, then such capacitors in parallel combination. Okay, there are two types of combinations, that are capacitors in series combination and capacitors in parallel combination. Now see, consider capacitors in series combination in which positive plate of capacitor C1 is connected to positive terminal of cell and negative plate of capacitor C3 is connected to negative terminal of cell. Consider capacitors C1, C2, C3 are in series combination in which positive plate of capacitor C1 is connected to positive terminal of cell and negative plate of C3 is connected to negative terminal of cell. Let phi be the total potential. Phi be the total potential. I current flowing through combination. As current flowing through combination, this current flows through this combination, charges on each capacitor becomes same, but potential is different for different capacitors, means this potential is divided into three parts like this: potential phi1, potential phi2, potential phi3, like this. as same current flows through each capacitor, charge on each capacitor becomes same, but total potential is divided into Phi1, Phi2, Phi3 across capacitors C1, C2, C3 respectively. See, if suppose CS, that is resultant capacity of series combination, Q total charge on this series combination, and Phi, that is total potential. CS resultant capacity, Q charge, and Phi potential across series combination, then CS is equal to Q divided by Phi, which implies Phi is equal to Q divided by CS. Suppose this is equation number 1. This is total potential, resultant capacity. If suppose Phi1, Phi2, Phi3 are potentials across capacitor C1, C2, C3 respectively, if Phi1, Phi2, Phi3 are potentials across capacitors C1, C2, C3 respectively, then potential Phi1 is equal to, what is potential? Charge you have a capacitor, that is Q divided by C1. Potential Phi2 is equal to Q divided by C2. Potential Phi3 is equal to Q divided by C3. But total potential Phi is equal to Phi1 plus Phi2 plus Phi3. This total potential is equal to Phi1 plus Phi2 plus Phi3, and therefore Phi, that is Q divided by CS, is equal to Q divided by C1 plus Q divided by C2 plus Q divided by C3. Q common काढून टाका. 1 divided by CS is equal to 1 divided by C1 plus 1 divided by C2 plus 1 divided by C3. Thus, reciprocal of resultant capacity in series combination, is equal to sum of, कशाची सम आहे? Reciprocals of capacity of condensers for n condensers of equal capacity in series combination. 1 divided by CS is equal to n divided by C, which implies CS is equal to C divided by n. Okay. Now, capacitors in parallel combination. What is capacitors in parallel combination? If parallel plates of each condenser is connected at a common point and negative plates of each condenser is connected to one another common point, then such a combination is called as capacitors in parallel combination. Now, consider capacitors in parallel combination in which positive plates of each capacitor is connected to positive terminal of cell and negative plates of each condenser is connected to negative terminal of cell. As capacitors are parallel, potential across each capacitor becomes same. But current flowing through each capacitor is different. Means this current is divided into different parts and hence charges on each capacitor becomes different. If suppose Q1 charge on capacitor C1, Q2 charge on capacitor C2 and Q3 charge on capacitor C3. As current is different for different capacitor, as current is different for different capacitors, charges on each capacitor is different. If suppose CP, Q, CP, Q and Phi are resultant capacity in parallel combination, total charge on combination and potential across combination, then Cp is equal to Q divided by Phi, which implies Q is equal to Cp into Phi. Suppose this is equation number 1. Cp, Q and Phi are capacity, resultant capacity in parallel combination, total charge and total potential across combination, and therefore Cp is equal to. If suppose Q1, Q2, Q3 are charges on capacitors C1, C2, C3 respectively, then Q1 is equal to capacitor into potential, that is C1 Phi, Q2 is equal to C2 Phi, Q3 is equal to C3 Phi. But total charge is nothing but Q1 plus Q2 plus Q3, therefore Q, that is Cp Phi, is equal to C1 Phi plus C2 Phi plus C3 Phi. Phi common काढून टाका, we get Cp is equal to C1 plus C2 plus C3 like this. Means resultant capacity in parallel combination is equal to sum of capacitance of capacitors in this combination. For n capacitors of equal capacity, resultant capacity in parallel combination is n times C. Is n times C. Okay. This is about capacitors in series combination and capacitors in parallel combination. Okay. Good morning. Today we have to see about capacity of parallel plate condenser. Capacity of parallel plate condenser. Capacity of parallel plate condenser. See. Consider a parallel plate capacitor. Consider a parallel plate capacitor like this. Consider a parallel plate capacitor consists of parallel plate capacitor consists of two metal plates P1 and P2 separated by distance d from each other with dielectric between them. यामध्ये आपण काय करतोय, डायइलेक्ट्रिक कन्सिडर करतोय. Consider a parallel plate capacitor consists of two parallel plates P1 and P2 separated by distance d from each other with dielectric between them. If let's suppose A, area of each plate epsilon naught, that is permittivity of air or vacuum, K dielectric constant, rho, that is surface charge density, that is quantity of charge per unit surface area. Rho, that is surface charge density, quantity of charge per unit surface area. Then by Gauss theorem, electric intensity of plates, E is equal to, what is electric intensity? Surface charge density divided by epsilon naught K, which is nothing but Q divided by A into epsilon naught K. Suppose this is equation number 1. By Gauss's theorem, फारते तुम्हारा Q charge on each plate, then by Gauss's theorem, electric intensity at any point due to plane conductor, that is E is equal to rho surface charge density of epsilon K, but surface charge density is nothing but quantity of charge per unit area. But electric intensity is defined as electric intensity, that is potential per electric intensity, but potential between plates, that is V is equal to E into T, and therefore V is equal to intensity Q divided by A into epsilon naught K into Hardy तसाच, and therefore capacity of plate is equal to, what is capacity? That is charge divided by potential, which is equal to Q divided by Q divided by A epsilon naught K into T. Q like Q cancel, therefore capacity C is equal to, हा भाग वरती जाईल, A epsilon naught K divided by T. C is equal to A epsilon naught K divided by D. For air or vacuum, for air or vacuum, K is equal to 1, and therefore capacity C is equal to A epsilon naught divided by D. This is capacity of parallel plate condenser. Expression परत बघा. Consider a parallel plate condenser consists of two plates P1 and P2 separated by distance d from each other with dielectric between them. If charge plus Q is added on plate P1, then an equal charge minus Q develop on near side of plate P2 and positive charge developed with escape from in plate P1 or from plate P2. Let A area of plate epsilon naught permeability of air or vacuum, K dielectric constant in surface charge density. By Gauss's theorem, electric intensity at any point near charged sheet rho divided like this, rho's value ठेवली. But potential between plates V is equal to E into D, value of E, and therefore capacity, what is capacity? That is charge divided by potential. Potential इथे घेतली, simplify केलं. This is capacity of parallel plate capacitor. What is capacity? C is equal to A epsilon naught into D. Now one more and last term in this topic about energy of capacitor. Energy of charged capacitor. Energy of charged capacitor during the process of charging. During the process of charging, work has to done on capacitor or conductor फारतं म्हणा. Work is done on the capacitor against electrostatic force. During the process of charging, work has to be done against electrostatic force. This work is stored in the form of electrostatic potential energy in the capacitor. This energy is called as energy of capacitor. See, समजा या ठिकाणी हा एखादा कंडक्टर आहे. यावरती समजा आपण काही चार्ज ऍड करतोय. यावरती समजा ऑलरेडी चार्ज आहे Q. दुसरा चार्ज ऍड होत असताना इथं जो रिपल्सिव्ह फोर्स निर्माण याच्या अगेन्स्ट वर्क करण्यासाठी किंवा होत असताना त्यावरती जी एनर्जी तयार होत असते त्याला म्हणतात एनर्जी ऑफ चार्ज कॅपॅसिटर. व्हॉट इज एनर्जी ऑफ चार्ज कॅपॅसिटर? ड्यूरिंग द प्रोसेस ऑफ चार्जिंग, work has to be done on capacitor against electrostatic force. This energy is stored in the form of electrostatic potential energy called as energy of capacitor. Expression. Consider a parallel plate capacitor. Consider a parallel plate condenser. If Q charge on condenser, V electric potential on plates of condenser. C, capacity of condenser. Then capacity of condenser is equal to Q divided by V. Suppose this is our equation number 1. म्हणजे त्याची ऑलरेडी एवढी कॅपॅसिटी आहेच. नाव if small q charge is deposited on conductor, if charge small q deposited on conductor which increases potential by V. If small charge q is deposited on conductor, increases its potential by V, then capacity becomes q divided by V, which implies potential V is equal to Q divided by C. Now work done to displace charge dq against electrostatic force. खरं तर त्याच्यावरती एवढं पोटेन्शियल ऑलरेडी आहेच. Now work done to displace or work done in bringing additional charge dq from infinity to that charge, that is work is equal to, what is work? That is potential into charge and therefore total work that is W is equal to integration of dW for this charge dq म्हणा. And therefore work done, that is integration from 0 to charge q phi into dq, but phi is equal to q divided by c, which is nothing but integration of q divided by c into dq from 0 to q, which is equal to 1 by c constant. Q's integration with respect to q, that is q square by 2 from 0 to q, which is equal to 1/2 q square by c. 1/2 q square by c. This is total work, and this work done is stored in the form of energy called as potential energy, and therefore energy of charge conductor E is equal to 1/2 q square by c. This is an expression for energy of charged conductor. What is energy of charged conductor? That is 1/2 q square by c. तर या ठिकाणी खर तर हा आपला टॉपिक इथं संपतोय, इलेक्ट्रोस्टॅटिक्स. ओके, नेक्स्ट टॉपिक ऑन नेक्स्ट पिरियड.